So I've had these notes posted since, I don't know when, October 6th. That's almost a month ago. Where is it? No, not October 6th. October 8th. October 8th was the first time I posted these notes. It's 3 weeks ago. My intention for posting notes, especially since during the first quarter, we really used my notes instead of the book. Okay, hold on a minute. Is Madison Batista with us yet? Okay. When I first posted the notes, I noticed that there was a little bit of a formatting issue because I did not use all graphics to represent the conversion factors. So some of the conversion factors down below, the formatting was off. There were spaces or tabs that were off. So I fixed them. I believe I fixed them. They look fixed on my screen. On your screen, it may still show off. But if you watch what I'm going to do with this, then you can fix your own notes, because every device display is going to shift a line of text more or less depending on, you know, the screen size, depending on the character or font size, depending on whether you have word wrap or not enabled. There's a number of things that will interfere with formatting, so you'll need to fix your own. Or maybe you can take your notes in picture format by writing on the screen or something. All right, so on the screen, you should be looking at my image of dimensional analysis. We don't have time for me both to teach this and to we don't have time for me to teach it from scratch and review for the quiz. I'm going to fly through this. So you see the scenario. You're here, your friend's here. You need to get from here to here. Now your friend is the A. Everybody wants to get to the A. All right? But you got to work for it. You got to build a bridge. So step one is to figure out where you start from. Step two is to figure out what the destination is, where to go. Step three is to build a bridge. It's a mathematical bridge. Now, the mathematical bridge is a series of multiplication steps. And let me get up and earn my living here. So it's going to look like, when you're done, it's going to look like a series of multiplication and division. Now the multiplication speaks for itself. You might ask, why am I going to divide it right after I multiply? Well, you're not. I mean, that is a division sign. You're going to multiply by a ratio. The ratio is made up of these equalities or identities that are all around us. 1 foot equals 12 inches. 1 mile equals 5,280 feet. 1 yard is 3 feet. 1 meter is 100 centimeters, or 1 centimeter is 10 to the minus 2 meters. It's the same thing, just move the 100 to one side or the other. So all of these identities or definitions that we have, all of these definitions about units or dimensions that we write are used to build these what are called conversion factors. A conversion factor is a ratio of two identical things, which means the conversion factor itself is equal to 1. Because if you make a ratio, of two identical things, it's equal to 1, right? So even if it's 2 plus 2 over 4. Even if the top looks different from the bottom, it is still equal to 1. Would you agree? Everybody says yes, of course. So even if you write a conversion factor, thank you, just put it on the desk. Even if you write a conversion factor, or excuse me, an identity like 1 cm equals 10 to the minus 2m, and you should know that. Since these two things are identical, if you were to put them on opposite sides of a ratio, then that ratio itself is equal to 1, because the top equals the bottom, even if it doesn't look the same. Just like this doesn't look the same as that. But it is. And so that's what we're multiplying here by. See, because you were taught in algebra, you cannot multiply the left side of an equation. Equations are joined, two sides joined by an equal sign. Can't multiply one side of an equation by something if you don't do the other side. Well, if it makes you feel better, then go ahead and multiply by 1 twice. You haven't changed anything, as long as you use here a conversion factor that is made up of an identity, where you define units. Okay, told you I can't reteach this whole thing. So let's just, I'm going to leave that there. Let's scroll down. That's that. There we go. And here we go. Oh, I know what I want. I want this. That. I want that screen. Okay. We've already talked about know where to start, know where to end, build the bridge. Now here, everything I just talked about, all the theory about building a conversion factor. Here is your conversion factor. Here's your conversion factor. This part right here, it's equal to 1. Here's the theory behind it. I just talked about it. I don't have time. You don't have time to keep talking about it. Read it, please. It'll explain why it works. It's math. Okay. Step 4. You should know this, even though I leave it out often. Step 4 is always, of every problem-solving technique, is always check yourself. Okay, now, here's what I want to work on. I want to work on this example. I want to work on this example. Because I'm trying to force you to look at it in non-unit ways. That's why the whole buffalo problem. I don't know, did anybody work the buffalo problem just to practice it? I'm not even going to look. It's embarrassing. You're supposed to study, guys. To learn, not to get a grade. To learn. Okay, so here's the example. Let's say you know that 3x's equal 2.1 y's and 7 y's equal 0.85 z's. Those are definitions. They're joined by equal signs. 3x's equal 2.1 y's. What does that mean? It doesn't matter what it means. I don't know what it means. But what it says is something equals something. So that is a definition. And for the sake of this problem, we can assume that it's perfect. It's exact. There's no doubt about it. It's a statement. It's not a measurement. It's not a count. It's a statement, a definition. So now we have a question. Question is, how many x's are in 3.79 z's? So in other words, we have to convert 3.79 z's from z's into other units called x's. So I'm going to work it right here. You can look over there, but that's a permanent record of my thinking behind this. And I did not invent this technique. I was taught this technique, and I put a lot of thought into why it works, what the logic is behind it, and that's all in the narrative below. So step 1 of my technique, building a bridge, is to write what you know on the left. Now I'm gonna work in this area right here. So the left side of this area is 3.79 z, and step 2 is to write what we're our destination. Our destination is destination A. Let me get to the A, which is the other side of the equation, where we have an answer. And the question is how many x's, so the answer is going to be so many x's. So this is equal to so many x's. That's our A answer. Now what we need to do is build a bridge of multiplication, by conversion factors that will get rid of the z, that's a z, and turn it into x's. So I'm going to need a statement that when I multiply 3.79 z's by that, it will cancel it out. So z here is on the top. You can think of it as a numerator over the denominator 1, if you will. Any number or anything can be written as a fraction over 1, and it helps you understand this is in the top, that's in the bottom. So if z is in the top here and I need to get rid of it, it's going to be gotten rid of by canceling it. It has to be written in the opposite position here, z. Now what I need is I need a ratio that involves the letter z that is equal to 1. In other words, the top and the bottom must be equal to each other. So let's go back and look at the supplies that I have that equate z to something. So I have something right here. I have 7y's equal 0.85 z's. Well, that's the only thing in my building materials. This is the Home Depot of this problem. The only thing in my building materials that include the letter z is this statement that 7y's equal 0.85 z. So I'm going to go ahead and put y on the opposite side, and then I'm going to put the 7 in front of y because that's what it says. 7y's equal 0.85 z's. And then I'll put 0.85 z's in, I'll put 0.85 in front of z. Now what I have done is I've set up a conversion factor equal to 1 because the top is said to be equal to the bottom, so that equals 1. So I'm not changing anything measurement-wise. I'm just changing the language with which it's expressed. There goes the z. Bye-bye. It's gone. Now I have converted z's to y's. You would think that that's not any closer to the answer, except we have over here, we have a definition that states y's equal to x's. In other words, I can express x's in terms of y's or vice versa. So I'm going to multiply this by one more conversion factor then that will get rid of the y. And on the opposite side of the y is the x, which is a good thing because that's the unit I wish. I read the definition, 3 x's, so I'll go ahead and put a 3 in front of that, are equal to 2.1 y's. Once again, I have set this up so that the letter that I do not want gets crossed out and introduces another letter. And in this case, it's a letter that I want. So I'm done. I just have to do the math. So now I end up with this math. 3.79 times 7 times 3, that's all on top, over 0.85 times 2.1. Now, don't get confused by this. On the bottom, in the denominator, it says 0.85 times 2.1. It's not 3.79 times 2.1. It's the top multiplied together divided by the bottom multiplied together. So I would suggest that you look at it like this. And that's how I would enter it directly into my calculator. I would literally say, you don't need to put parentheses, but you can, 3.79. You definitely need parentheses in the denominator when I show you what I'm going to do. I would then hit the times key. I would hit the 7. I would hit the, you should take out your calculators and do this. Everybody watches me and they're like, oh, it's 3rd grade mathematics. I can do that. And then you get on the quiz and you're like, oh, shoot, I don't remember what he did. You can't learn it unless you practice it. It's like standing at football practice and watching a great play being run, introduced, and I'm like, it's just running and catching a ball. I can do that. Yeah, sure you can, but you got to do it in a certain order. You don't learn that order until you practice it. So I'm now going to hit the close parentheses key. I'm going to hit the divide by key. I'm going to hit the open parentheses key. I'm going to hit the 0.85 times 2.1. I'm going to hit the close parentheses key, and then I'm going to hit the equal sign. We have time for one practice with the real digits, and then we'll take the quiz. 3.79 times 7 times 3 divided by open parentheses 0.85 times 2.1 close parentheses equals, and I get a long number, 44.588235529. And if I wrote that in math, teachers would be high-fiving me. You're a math star. But in chemistry, they want to know, in physics, astronomy, molecular biology, biochemistry, they want to know that you know the limits of your exactness as well as the answer. So we look at our, these are all, notice, these are definitions. These all come from definitions, so they do not limit us. They have infinite significance. So the limit to our sig figs is the original starting number, 3.79. Remember, definitions, I told you this way at the beginning, definitions and counted numbers are considered perfect. So we don't have to worry about, do they affect our sig figs? So we look at the original number, we see 3 sig figs. So we're going to come down here and cut off the smaller numbers. We keep the big numbers. 44.6 is the correct answer. 44.6x is the answer. Got to have units. If you write it in the original blank that you wrote, which is supposed to guide you to writing out the right answer, you'll be reminded that it's not a raw number. It's actually a number with a unit. Anybody have any questions over this approach? Everybody seems to, oh, I watch you do it. It's easy. And then I can't get past step 3 or step 2 of writing where to go. It's a logic thing. You're trying to multiply by ratios that cancel out the units that you don't want and get the units that you do want. Let's do a quick one. Let's do a quick one. Ready? Unless somebody has a question. Now this is all, everything I just did is thoroughly written out here, and I fixed the formatting on today's notes so that you can see the fraction. I hope it's fixed. I mean, again, your display and font size defaults will affect that. Let's try another problem. A jet is flying at 892. Oh, that's not 892. 892.7 kilometers per hour. How many centimeters per minute is this? Okay, so you should be able to set up the first 3 steps. You should write what you're given on the left. You should be able to write what you requested on the right, and you should be at least set up one conversion factor with 1 unit in it. If you can't do that, then I don't think you've been listening to me or reading or preparing in any way. And you should go to your parents and say, look, I am so not invested in this class. I'm going to get a bad grade because I just don't care about it. Please don't torture Mr. Baytall. He's not a cheerleader. He's a chemistry teacher. Okay, I'm not a cheerleader. I don't know how to make you do something you don't want to do. I know this is boring. All I can do is beg you to learn it because it will grow your brain, and you will use unit conversion in your life. I promise you will. It's not like deep, archaic chemistry with quantum mechanics that you're like, when am I ever going to need this? You will use this. Buying paint, buying carpet, buying drywall, cooking. Give you a minute or two to set this up. I'm not even checking. I'm gonna give you a minute or two to set it up, and then I'm gonna set it up, and then you're gonna check yourself, and you're gonna say, hey, I'm getting this, or hey, I'm not getting this. And if you care, you're then gonna ask me, Mr. Baytel, I didn't get what you got, you know, and I within the few minutes that remain, I'll try to help you. And if you really care and we don't have time, then you're gonna have to just contact me and say, Baytel, I need more tutoring or something, or I need more help outside of class.
Mister, do you have tutoring for chemistry, like after school?
There is, the school offers tutoring. I could offer a special session at some point if you know, people needed it or wanted it. Sometimes it's helpful to hear another teacher like Mr. Weiss across the hall. He does Zoom tutoring. He also does in-person tutoring. Sometimes it's helpful to hear another teacher explain it.
Wait, but is he like on the same lesson as you, or is it like?
He's approximately, we chemistry teachers are in the approximate same vicinity. Like I know Miss Guevara across the hall finished dimensional analysis when I thought I was finished with it, like a week ago or more, maybe 2 weeks ago. But I've come back to finish the job because I realized people didn't get it. But we're in this, and any chemistry teacher that's tutoring should be able to teach any other lesson, even if they're not on it.
Okay. And then if I'm virtual, could I go to the physical tutoring after school or no?
I don't know if anybody would stop you. He offers Zoom tutoring, but if you want to get into the physical, don't ask questions, right? Just show up and go. If they ask questions, then you know. Now, if you're quarantined, don't do it.
No, I'm not quarantined.
Okay, if you're MSO by choice, that's after school. I don't know that they would. I just don't know that that's been prohibited yet. So until it gets prohibited, I'd say try it.
All right, thank you.
Come on. Have a good one. All right, I'm going to go ahead and set this up because we're running out of time here. Write what I know on the left, 892.7 kilometers per hour. Write what I'm requested on the right, equals blank centimeters per minute. Now notice this is a complicated unit. It's got a numerator and a denominator. We're looking at distance to distance, time to time. Remember, I said don't try to bite off the whole thing. You'll go crazy. Convert distance to distance, and then add a new factor for time to time. So that's what I'll do. What do I know about a kilometer? 1 km. Oh, here's what I told you. Step 3, everybody should have had at least this much written, and even more. I default to changing the numerator to the numerator first. It doesn't matter which one you do first. But if you're choosing to get rid of kilometers first, everybody should have been able to write that without even knowing anything further. If you are not able to get at least that much, then you're really not. If you're paying attention, if you're listening, If you're studying and you still can't get this, then we've got a disconnect somewhere. There's a communication error, there's a thinking error, a perception error, and we've got to diagnose that and fix it. If you know the problem is you just haven't put the time in on practicing, then you've just self-diagnosed and you need to treat it. You need to get more practice. Okay, so this tells me I need a relationship between something and kilometers that is based on an equality. So I'm going to write an equality. 1 km is equal to 10 to the 3 m. That comes from the chart on page 13 that you should have memorized. That means I put 1 km together and I put 10 to the third meter on the opposite side, and that gets rid of my kilometers. But I'm not done yet because the answer is in cm. And so now I write something about cm's. 1 cm equals 10 to the minus 2 m. So I'll add another conversion factor that gets rid of meters because I don't want meters. I'll put meters on the bottom to cross it out. I look at my new conversion, my new identity. 1 cm is 10 to the minus 2 meters, and I know that 10 to the minus 2 goes in front of meters, and 1 cm must go on the other side, which is fantastic because that gives me the unit that I want, centimeters on top. I'm now technically finished with converting distance to distance. I must convert time to time, and so there's I need another statement that defines hours, because I'm going to now multiply by a conversion factor, and I made it that big because I already know we're going to be done with one more step. This is it. I need to get rid of hour, so I'll put hour on top. Now I need a sentence that relates hours and something else. Well, I'm going to minutes. Does anybody know the relationship between hours and minutes?
1 hour equals 60 minutes.
Thank you, Rockstar. All right, there we go. So 1 hour, 60 minutes. And hour cancels as we intended because we put it on the opposite side, and now we have a math problem. 892.7 times 10 to the third divided by 10 to the minus 2 divided by 60. Centimeters per minute are the units that survive. Centimeters survived on top, minutes survive on bottom, centimeters over minutes. So we really have this problem. Think about it, 892.7 times 10 to the third. I'm going to rewrite the bottom so it looks like scientific notation, 60 times 10 to the minus 2. Now, I could do that as two scientific notation numbers. I could say 892.7 exp3 divided by 60 exp negative 2, hit equal and be done. I could also do this manually. I could say that I can simplify the 10 to the third, the powers of 10, and I get 892.7 over 60 times 10 to the fifth. So 892 divided by 60, 892.7, let's not forget the 0.7, divided by 60, 14.8. Now, we're at 4 sig figs. I'm going to write it at the top. I get 14.88 times 10 to the fifth centimeters per minute. Move this over 1, making that smaller, making this bigger, and I get 1.488 times 10 to the 6. It's 1.5 million centimeters per minute, roughly. Questions?
Wait. Yeah, mister, I don't know where you got the 1488 from.
I did
Not gonna-
math. I did this math right here. Or if you're 2 steps behind me, I did this math right here. I went from there to here.
Oh, okay. I didn't see the there to here. I just saw the there and not the here. I'm sorry.
Okay, so the question is, do I always go to meters? I do, because I memorize the chart.
Yeah, the chart.
I don't do the King Henrys. I know with King Henry you can go boom, 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 boom. And I don't do that. I go from the prefix to the base unit. I go from the prefix unit to the base unit, and then I go from the new prefix unit to the base unit, and that's how I connect it. I connect it through the base unit. So notice I end up at meters and I get rid of meters. That's like taking a bus to the Grand Central Station and then, you know, all the buses and subways in New York City go through Grand Central basically. So it's like the hub, and the base unit is like that. So everybody gets to meters or whatever the base unit is before they move on. Okay, it's like changing a train there. So it's 1.488 times 10 to the 6 centimeters per minute. Guys, we got to take our quiz. So what I need you to do is put everything away except 1 or 2 sheets of blank notebook paper. You can have 1 or 2 sheets of blank notebook paper, a pen and a pencil, and your scientific calculator out. You're welcome to use your scientific calculator. You cannot have the table. You cannot have any references. You cannot have any other web pages open. You do need to have your portal email open, and when you click the link, it will open a browser window that takes you to the quiz. So you know you're going to have that browser window open, but you can't Google anything. You can't open the textbook up and have that table. I mean, at some point, I think I am going to. At some point, I think I am going to open quizzes and tests up to open book and open notes, but not now, because this is so basic, and that table is so important. You should have committed it to memory, and I want you to. All right, watch your email. Please let me know if you do not get the email. I'm going to send it in just a second. I'll let you know when I've hit enter. I'm also going to add my name to it so I can see when I get it. Okay, let's see. All right. I'll let you know. It's about to happen. Guys online, make sure I can see your work areas, please.